there in person, but I couldn't due to the birth of our first son, so here I am joining virtually. So today I'm going to talk about the ways that exist today to do video conferencing in ways that you can actually use, right? Where I come from, I am the founder and project lead of the Jitsi VideoBRIDGE project, open source project. We have been working it out for the last 11 years, so it's been a while. Many of you maybe know the product as SIP communicator. Originally, it was this audio video communicator that you can use with SIP and XMPP, primarily for audio video calls, presence, instant messaging, etc. So for a number of years, the Jitsi was evolving as this feature bridge communicator. Actually, our business was based on developing new features on demand, so we actually had a bunch of them. I would say that we probably stayed the most feature bridge communicator, open source one. So we implemented things like recording, forward direction, traversal, online provisioning, and a bunch of other interesting features. And for a while, people were using Jitsi mostly as a way of competing with Link or Skype, and then they would use backends like Elastic actually, or rather SIP servers to actually provide the server state. And then among these features, one that was particularly interesting was the conferencing. Jitsi at the point was able to establish conferences since actually its very early years. Originally, these were only audio conferences, and we liked it. It wasn't the most popular feature in the project because normally when people do conferencing, they like to have their own conferencing server, passwords, invitations, and everything. But we thought it was quite nice to be able to do that at a point. And we implemented a bunch of interesting things like the possibility to see everyone's audio level even when you're not in the mixer. So even when you're getting a single mix audio stream, it will allow you to see. Actually, it was something that we standardized at the ITF, and that's going to come pretty handy later on in the rest of my presentation. By the way, if at any point anyone has any questions, please don't hesitate to interrupt me. Now I'm moving to the part that is actually more relevant to the talk today, and that is that at one point we thought, okay, we have audio conferences, this is cool. Now, what can we do about video? Could we also use Jitsi as this? And we thought, sure, why don't we try and party conference meeting at MCU. But why don't we try some quick question. I'm having a video freeze right now. I hope you're still hearing me. We created this thing, so it was possible for Jitsi to join conferences, but it was a successful feature, and then we thought, why don't we put that on the server, actually make it even more alive? I'm going to talk about the kind of servers that operate in video conferencing the same way as Jitsi VideoBRIDGE does. Those servers that are called selected for the units. contributing to algorithms particularly efficient. Making video conferencing a very successful field. And about the last year, we added, and this is where Jitsi was the only one that was able endpoints, and we're also able to use it. So that was great. After what Users Conference hosts their show on Jitsi Video, 500th edition went introductory, then CBO. We're quite proud of. And while showing screenshots, I'm actually when doing some second grade way of mixing first grade video conferences.
Emil?
Yes.
Sorry, we had some problems with the internet. We're going to try another connection. Okay, could you hold on for 2 minutes, please? Are you there? Woo! Emil, are you there?
Yes.
Okay, great. Sorry for the inconvenience.
Yes, I can hear you again. Can you hear me?
Yes, okay. Yes, gracias por la espera y disculpen la interrupción. Go ahead.
Yeah, so I want to reassure you, I'm not going to repeat everything that I just said, so I'm going to pick that up. It was just the history part that I'm so important. I'm going to get to the meat of the presentation, which is really about how these things work and how they can be optimized. We're having problems hearing me, or something, just give me a sign so that I can. Although if you are having problems seeing me, then probably I don't have much of a problem to get you, but we'll see about that later. This is why this new approach to video conferencing works. Why I insist on the fact that it is not something that we have invented. People have been doing conferencing like that in a number of other applications. Google Hangouts use the people router for the same purpose. Skype was actually implementing video conferencing that way, and still is. And the main difference here is that everything that I'm talking about is open source. But again, most of the mechanisms that I'll just describe now apply to all kinds of servers, and they're not specific to Jitsi VideoBRIDGE. So they're mechanisms specific to video routing or using selective forwarding unit. So one of the advantages of using selective forwarding units is that you get to build whatever interface you want. The videos that you rendering are just separate video streams. You can show them whatever you want the user to choose, whichever one it wants. You don't have to implement 10 different kinds of layouts in your mixer. You can do that in the drawing where it belongs. Now, if we're going to talk about other ways about how to manage this way of living conferences, it's worth reminding what other ways of living conferences exist. Since the arrival of WebRTC, people have experimented a little bit building full mesh conferences. I'm not really going to explain why this isn't a good idea. It's just that full mesh conferencing doesn't really scale for bandwidth reasons, for CPU reasons, for connectivity reasons. It's just not a good architecture. I'm not going to get things and reasons, but if you'd like me to just ask later. The approach that most of you have probably been used to in the past is using video mixers, using the well-known MCUs. And the idea of an MCU is that any participating video client will be talking to that server instead of talking to another video client. It will be getting one single video stream and one single audio stream, and it will just be showing them their own user. Now, while this has been a good idea for a while, especially when clients were hard to build, it is also an extremely expensive one, because the more you scale, the more expensive it gets. You basically need about a core render up to 6 participants in a specific conference. So imagine if you want to build some massive service, how expensive that is going to be. And the cost isn't really the only issue. There are issues that are related to latency, to added jitter buffers, to additional decoding, transcoding, that really impact the quality of conferencing. One perceived advantage of MCUs is their ability to use less bandwidth than supposedly SMU. And that's one of the myths that I'd like to debunk today. Someone recently told me you're never going to be able to take an Android and make it into an SMU, because it's just never going to have enough bandwidth, it's never going to have enough CPU to show all the participants in a conference. While from a first glance that might appear to be true, it isn't really, because people have been aware that just routing every video stream to everyone does require more bandwidth, and SFUs during the past years have implemented a bunch of different techniques that have allowed them to optimize for different sorts of endpoints, different sorts of connectivity, and I'm going to go over these techniques now. One of the first mechanisms that come to mind, and that we have actually recently implemented within Jitsi VideoBRIDGE, is the use of simulcast. Now, simulcast is this idea that every user participating in the conference will be streaming 3 different resolutions to the video bridge. Why would you need that? Well, remember, an SFU, a video router, does not do any transcoding. It does not really look into the video packet, so it cannot adapt what it is sending to the different endpoints that are receiving it. So the idea of simulcast is that rather than doing that in a mixer, well, you would subcontract it to the client, basically. So you would have all the clients and 3 different resolutions or 2 or whatever is appropriate for your application to the bridge. And then the bridge, the SFU, would only forward one of them to the endpoint that you're communicating. And this is the key point. Which one is it going to forward? That decision is going to be made based on a bunch of different criteria. So obviously, one way of doing that would be to just say, I'm going to set high quality for whoever is currently speaking and low quality for everyone else, because everyone else will be hearing me differently. Right? So this is something that is specific to, that is a decision that is specific to an application, but you can also make decisions based on the kind of connectivity that you're currently using. So let's say that you have a fiber or cable or high bandwidth connection between a receiver and the SFU. Well, in that case, you can just forward the high quality stream. But if someone is connected over Wi-Fi and the bandwidth estimation there is providing lower numbers, then we can switch to a lower quality. Then obviously, if you are on a mobile with a higher bandwidth constraint, if you can just relay the lowest quality version. The estimations obviously are not done based on actually knowing if your connection is cable or Wi-Fi. There are a couple of drafts of the ITF that I have here at the bottom of the slide that actually tell you a couple of nifty tricks about how you can measure your bandwidth and estimate based on your current bit rate, based on the inter-arrival jitter of packets that are arriving. You can determine with pretty good reliability exactly how much bandwidth is reaching. So basically this allows you to end with a conference where you have 10 participants and you're only getting high bandwidth consumption for the active speaker and you're getting low bandwidth consumption for everyone else. And even then, even for the active speaker, you can get low bandwidth consumption based on if it turns out that you don't have enough bandwidth. Now, this is obviously applicable also in the sender side. So if maybe somebody would say, wait a minute, does that mean that I have to have enough upstream bandwidth to send 3 different resolutions? Well, no, not necessarily. Obviously, if you did have that much bandwidth, that would be great. If you don't, then you're going to use the same bandwidth estimation algorithm. And you would drop your highest quality layer, for example. And if you didn't even have enough bandwidth to screen 2 layers, then you will only drop to your lowest quality layer. And again, you would be adapting really reliably to the network condition. It's probably worth pointing out that things are something that we implemented very recently, so they are not actually deployed in this platform. So, which probably would have helped with some of the we're experiencing right now. So moving on. Again, this was everything that we've seen so far is something referred to as simulcast. It allows to optimize the bandwidth used for and by a specific participant. Other people are actually using the same thing as with techniques known as SVC, scalable video coding, which is basically the same thing, but it happens within the code, within the encoding. Now, another way of optimizing high participation in video conferences is by using what we refer to as last N. The idea is that in a conference where we have 100 participants, rather than seeing all 100 of them and having to decode all 100 of them, you would just be getting the last N who actually spoke. You would be completely ignoring people who are inactive. Obviously this is, again, this could be implemented first based on the use case. You always know that you have a static number of 5 people and once you're just showing the last set of the speakers. But again, this could become pretty interesting if you combine it with bandwidth estimations. And once again, imagine that you're on a good connection, you can, without a difficulty, you up to 10 streams. Well, you're going to get 10 streams. But if you're on a worse connection, then the SC3 is going to detect that and is going to drop your the number of participants that it's sending you only to only 2 or 1, depending on how much you can afford. Now, another interesting aspect here is the way we do dominant speaker detection. As you've seen so far, a number of things that we do, we rely on knowing who the dominant speaker is in a specific conference. And then some of you are probably thinking, how am I going to know, how is the message, how is the video router going to know who is the dominant participant if it doesn't have access to the audio data, if it doesn't have access to the video data? Remember how in the beginning of the call I told you about these user levels that we were sending with Jitsi? That was that's part of the equation. Now the actual calculations are. I'm going to go through these slides because we don't have much time remaining. But the actual events are being sent to data channels, WebRTC data channels. This is at least how we do that in our implementation. Obviously, you can also use other mechanisms if you need to. Now, the question is, how do you calculate, how do you do the actual calculation? And we personally chose to use this, the mechanism described in this paper by Lana and Cohen, which basically provides correlated averages on a bunch of audio level values that we gather over periods of 2 seconds, 200 milliseconds, and 20 milliseconds, and then we try to come up with a reliable estimation of the dominant speaker so that A, you don't have too frequent changes, and B, you actually know when someone is the dominant active speaker. And now we come to this part where how does the SAT know who is talking when it's not decoding the audio? How is it going to understand who is currently the active participant, the active speaker? And the way we do that is with these RFCs that we actually specified a number of years ago, 5 years ago maybe, we started this in 2009. We did it with Jonathan Lennox from Video and Rick Moore from Italia. And when Google started working on Chrome for WebRTC, well, lucky us, they decided to actually implement these RFCs. So today, in every audio packet that comes out of Chrome or Firefox, for example, you have an audio level estimation that tells you this is how loud this packet is. So basically, this way a video router can know even without encoding who is currently speaking, who is currently making noise, and who is actually going to speak. And this allows us to implement much of the techniques that I just described. So with all these techniques in mind, I think today everything that an institute can do can also be done in messaging. The reasons that people were using MCP before are no longer relevant. We have more bandwidth, even when we don't have the mechanisms that allow us to adapt to the actual behavior we're having. Just to give you a perspective, I told you that if you want to have a mixed in the conference, you need about a core for every 5% participants. You could probably cost 20 times, at least 20 times that much when you're using video routing. And that is provided that you're actually terminating encryption, which is necessary for WebRTC. But we're hoping that things like SRTP will get adopted there, and we'll be just performance will probably just be multiplied by 100 at that point. But even today, it is possible with a regular virtual machine to host 100 cameras. On video conferences, you basically get zero performance, or better performance than with additional. Now, one of the last things that I wanted to address today is, if we have 5 minutes, we'll do that right now, was, okay, so you have this funky architecture here doing video conferences, everyone's getting a bunch of video streams. How am I ever going to make that work with my signal? No video client ever is going to be able to receive multiple streams. No audio client is going to be able to receive multiple audio streams unmixed and then play them simultaneously. Well, this is where we actually, the digital community, we have this SIP gateway that we call Jitsi, the Jitsi gateway for SIP, which allows us to do exactly this. Jitsi is actually a Jitsi instance, Jitsi client instance running on a server, and the way it works is that it will connect with the bridge conference on one hand. It will use the XMPP signaling that we have there in order to point the conference, in order to start the audio streams and everything, and then it would, on the other hand, it would get a SIP call. It would mix all the audio streams that it is getting, and it's going to send them to the users. Now, I didn't say mix, it is going to mix it. This does break the scalability and the performance of the Jitsi VideoBRIDGE, but the thing is that you would run a SIP gateway on a different machine from a VideoBRIDGE. So if you need to scale these things, you would need to scale them differently, you need to be able to scale them differently. Because they would be living separate lives in separate machines, and you can have all of your video participants on using one infrastructure, and however they need to be able to go into SIP, well, that's how much resources are going to be provide for the mixing gateway per SIP. This is actually something that was that we were able to implement thanks to funding from various companies. Some of them remain anonymous, but tip-wise, it was actually someone who had to finish and finalize this, so I'd like to express our gratitude to them. And just before I go, here's basically how your SIP scenario would work with Jitsi VideoBRIDGE. You start by having this simple conference, just like any other conference. Every stream, this is one conference, so every stream is being redirected to everyone else. Now imagine that you want to have here someone who wants to join this SIP. You have an outgoing call number 124. This is where the Jitsi gateway comes in. This lives on a separate machine, and when you want the SIP participant to join, it basically just establishes a call. It receives all the audio streams from the bridge, it mixes them, it sends them to your ElastixWorld, for example, as a mixed stream, and whatever comes in the other direction is being sent to the bridge and sent to every other participant. You can actually choose to turn off encryption on the communication between the VideoBRIDGE and the SIP gateway, because presumably these are all going to legal normal infrastructure, so you won't need to protect them if you have other means of guaranteeing security. And if you have an outgoing call in the same conference or an incoming call, that would actually be working exactly the same way. Outgoing streams, including that of the other SIP participant, would be mixed and sent to the Elastic server, and then everything in the opposite direction would be sent as sent to all participants. And I think we're just about out of time, but a little bit quickly, but I managed to go through everything that I had planned for today. I really hope that you were able to hear something, and if you were, please don't tell me, Yes. So I would be happy to answer any questions if you guys want to ask anything.
¿Hay alguna pregunta de parte de la audiencia que quieran hacer en mí? ¿O por correo?
Hola, Juan Carlos. La persona que está dando la conferencia, ¿tiene alguna forma, alguna herramienta de darse cuenta que los otros participantes no tienen una buena calidad de audio y de imagen?
Okay, it's asking that if the person who is giving the conference has any way to know that the audience or part of the audience, any of the people that are on the conference has problems with the audio or the video.
Actually, yes, because if you, and we're currently talking about something that's specific to our Jitsi application. This is not different implementations can resolve this problem differently, but if you have a look at the thumbnails here, you would notice that there are GSM bars. I'm going to put my hand here so you can see them clearly. There are GSM bars in the upper corner of every thumbnail, and when you go on top of them, I don't know if Paul, if you hover your mouse on top of one of the GSM bars that you're seeing in the thumbnails. But if you do that, you see that they show you percentages as packed to close and your current bit rate and estimated bandwidth. So this is something that we implemented recently. We're still working on it. It still has these patches to see there, but it's something indeed that is good. That's a good question because it's something that users often want to know. Are people caring about that?
¿Alguna otra pregunta?
Hola, yo, Federico. ¿Va a haber alguna integración con el Elastix, aparte del SIG Gateway?
Okay, he's asking if there's going to be any integration with Elastix apart from the SIG Gateway you already mentioned.
Dime. Ahí nomás.
I'm sorry.
Okay, he's asking that you're planning to have an integration with Elastix, not related with the SIG gateway you already mentioned.
So I just to make sure I heard the question was if there going to be integration with Elastix. We would love for that to happen. This is the short answer. We haven't currently done anything so far, but basically this is the Jitsi gateway is a simple client, so you can connect it to any SIG server, including Elastix and any SIG environment with Elastix. But we think it would be a great thing to have better integration about setting up and deploying the whole system. So that's certainly something that we'd be interested in working on. So. If anyone else is on the Elastix side is interested in that as well, please contact Emil at Jitsi.org and we can put words into action.
He says he can do it. Please stand up.
Excellent.
Yes.
Excellent. Please mail me. We can chat about this.
Can you put your email on the screen so that people can take a note of that?
Yeah. Yes, I'll do that right now.
¿Alguien más tiene una pregunta?
So, yeah, that's it.
Great. ¿Alguien más tiene una pregunta para Emil?
So you could guess the
Yes.
address.
There's another question.
Ahora sí. Hola Renato, te quería preguntar, he notado durante la conferencia que hemos perdido varias veces el video, pero no así el audio. Mi consulta es razonable suponer que Jitsi prioriza la voz sobre el audio cuando existen pérdidas de velocidad?
Okay, he's asking that he noticed that during your conference there was a loss of video sometimes, but audio was flawless. He wants to know if Jitsi put priorities on the audio over the other companies on the conference.
No, actually, we don't, and the reason the audio was so good is because it uses Opus, which uses things like order, correction, packet loss concealment. It actually varies its bit rate based on the conditions that we're seeing. So it's just that the codec is much better at adapting that to network conditions. And video, unfortunately, isn't there yet. Although some of those mechanisms, such as order correction, for example, are being adapted to video, and some of them are actually being used in what we're doing here today. It is, well, video just needs much more time. So it's harder to make sure that it gets there. Also, some of these mechanisms consist in downgrading to some of the mechanisms for guaranteeing video quality consist in downgrading quality. So you would notice basically that there are problems even if the mechanisms that are kicking in. So these are the reasons. I hope that was answering the question. I'd just like to conclude, actually there is one case where we do prioritize video, but this is disabled here. Sorry, where we prioritize audio, and this is disabled here. And that is, if we detect that we don't have enough bandwidth to send you both, we can disable video. This is what we call adaptive last end. This is what I talked about. This is disabled here, yeah, but this is a feature that we do have. And then in a minute, we'll try to send video again. We'll see how it goes. If it's still crappy, we're going to cut it off again, and so on and so on.
John Bonilla, who's here, he wants to see a picture of your kid. Emil, thank you very much.
Yeah, well, I'll send you one later, Joe. Thank you very much, guys, and hope to be there for real next time.
Thank you, Emil, and thank you all for being part of this experience to share Jitsi and the power of Jitsi to do video conferencing. Thank you, Emil, and congratulations for your newborn child.
Thanks. Thanks. Bye, guys.
Bueno,